Hello students, I have told you the numerical part of NEET 2019 series H1 up to the 15, and today I am taking from 16 to approximately 22 numerical questions. And I have told you earlier that you watch the video completely so that you could understand that how to interpret the language of the question and how to understand and how to apply the formula for the solution of the question. So I am taking here the question number 16 to 22. So now question number 16. A proton and an alpha particle are accelerated from rest to some energy, to same energy. The de Broglie wavelength, lambda p and lambda alpha, are in ratio, Now option is first 4:1, second 2:1, third 1:1, and now fourth √2:1. Now solution. Now in this question you are asked the de Broglie wavelength of proton and the alpha particle. As we read this question, that this should immediately come in mind that the mass of the alpha particle is 4 times the mass of the proton, and this is also given that they are accelerated to the same energy. So lambda equal to h upon square root of 2mp. This is the formula. Then for lambda p is equal to h upon square root of 2mp into e, and your lambda alpha is equal to h upon square root of 2m alpha into e. Energy is the same. For both this is given that energy is the same. So lambda p upon lambda alpha is equal to h upon square root of 2mp into e into h upon square root of 2m alpha into. Now here you see that all terms will cancel except m alpha and mp. This h will cancel by this h, e and 2 this will cancel by this one. So we are left only with square root of m alpha upon mp. And this we know that m alpha is equal to 4 times mp. So this is equal to square root of 4 times MP upon MP. Now this will cancel. Square root of 4 is equal to 2. So this is not 2 upon 1. So this is not 2 raised to 1. So our right answer is second. This is now second. So what you do that as you read the question, directly apply the formula and see the energy is the same. And remember that the mass of the alpha particle is approximately 4 times the mass of the proton. And then you find the ratio. Now I am taking the question number 17. Now question number 17 is given to you. An object kept in large room. An object is kept in large room having air temperature air temperature 25 degrees Celsius, 5 degrees Celsius, takes 12 minutes. Takes 12 minutes to cool from 80 degrees Celsius to 70 degrees Celsius. The time taken to cool, the time taken to cool for same object from 70 degrees Celsius to 60 degrees Celsius would be nearly number 1. The option is 15 minutes. Second is 10 minutes. Third is 12 minutes. Fourth is 20 minutes. 20 minutes. Now here you see that the question is given for the Newton's law of cooling. So here we apply the formula Newton's law of cooling. Newton's law of cooling. Now this is theta 1 minus theta 2 upon T equal to a constant K. Theta 1 plus theta 2 upon 2 minus theta 0. This is the formula. Theta 1 theta 2 are the temperatures from which the body cools. Theta naught the temperature of the atmosphere or the environment. That is given here 25 degrees Celsius. This is given 25 degrees Celsius. So first given 80 to 70 degree and then this 25 degree. You have to find the value of K with the help of this one. So now this we take 80 minus 70 upon t is your 12 minutes. 12 minutes equal to k into 80 plus 70 upon 2 minus 25. So this is your 10 upon 12 equal to k into, this is 150. 150 divided by 2, so this is now your 75 minus 25. So this is your 10 by 12 equal to k into, this is now your 50. So by 10 this will cancel out 5 times. So from here k is equal to 1 upon 60. This is the value of k. Now then again this is given that the same body is being cooled from 70 degrees Celsius to 60 degrees Celsius. Now in that case we have to use this value of k and then you have to find the time. So again this theta 1 minus theta 2 dash कर देते हैं इसको upon t dash equal to k into theta 1 dash plus theta 2 dash upon 2 minus theta naught. Now theta dash is given to 70 and theta 1 is 70 and theta 2 is just 60 degrees Celsius. So now we do it. This is now your 70 minus 60 upon t dash equal to k. Now k is equal to 1 upon 60 and this is your 70 plus 60 upon 2 minus 25. So now we calculate this is your 10 upon t dash equal to, this is your 1 upon 60. This is now your 130 divided by 2, so 65. 65 minus 25. And this will give you 10 upon t dash equal to 1 upon 60 into 65 minus 25. So this is now 0, so this is now your 40. Now this 0 will cancel and this by 3 and this by 2. And this 2 cancel this by 5. So here we get t dash equal to 3 into 5, 15 minutes. So our answer must be what? This is now first answer. So just we apply the law of cooling and you remember this formula, theta 1 minus theta 2 upon t equal to k, theta 1 plus theta 2 upon 2 into minus theta dash, theta or theta 0. Now question number 18. Now question number 18. Two small spherical metal balls. Two small spherical metal balls having equal mass equal masses are made from materials of density densities rho 1 and rho 2, and this is given that rho 1 equal to 8 times rho 2. respectively. They are made to fall vertically. They are made to fall vertically. In a viscous medium. Whose coefficient of viscosity equals to eta, and whose density is density is 0.1 rho 2. The ratio of their terminal velocities. The ratio of their terminal velocities could be number 1. This is now your 79/36. Second is 79/72. Third is 19/36. And fourth is 39/12. Now the solution. Now this is given that the two spherical balls having the density so and so relation is given here. Rho 1 is equal to so much, rho 2, and the density of the medium is also given here, that is 0.1 rho 2, and this coefficient of viscosity is given the eta. So now terminal velocity. V equal to 2/9 eta upon r square upon eta into rho minus sigma into g. This is the formula. So now you are given 2 volts. So this is now your V1 equal to 2/9 R1 square upon eta into rho 1 minus sigma into G. V2 equal to 2/9 R2 square upon eta rho 2 minus sigma into G. Now what we have, this V1 upon V2. You know that these factors will cancel. So this is now your R1 square upon R2 square into rho 1 minus sigma upon rho 2 minus sigma. Now here this is given that this rho 1 equal to 8 rho 2 and sigma is equal to 0.1 rho 2. This is given to us. R1 is given 1 mm and R2 is given 2 mm. So this is equal to 1 whole square upon 2 whole square. You remember that this is given in the millimeter, so both are in the same. They have this is the ratio, so no need to convert them into the meter because that will cancel. So we can use directly to this formula. Rho 1, this is now 8 rho 2 minus sigma 0.1 rho 2 upon this is now your rho 2 minus sigma 0.1 rho 2. So now rho 2 will cancel. This is now 1 upon 4 into this is your 7.9. This is 0.9. Now point will cancel from both. So this is equal to 79 upon 36. So this is what the answer? First. So our answer is first. This is the direct application of the terminal velocity. Only you have to remember that rho 1, rho 2, sigma and the radius that is to be used in this formula. And now question number 19. A particle standing from rest is stationary. A particle is stationary, starting from rest. A particle starting from rest moves in a circle of radius r. Moves in a circle of radius r. It attains a velocity. It attains a velocity v0 meter per second in nth round. In nth round. Its angular acceleration will be its angular acceleration will be number 1 v square upon 4 pi nr radian per second square. Second, v naught square upon n radian per second square. And third is v naught square upon 2 pi n r square. 2 pi n r square. So much radian per second square. And now fourth option is v naught square upon, so now 4 pi n r square. 4 pi n r square. So much radian per second square. This is the options given here. Now you can see that this is the question related with the circular motion, and we know that the equations given here in case of circular motion. So its solution. Just like the motion of the particle in a straight line, we have the three equations: v equal to u plus at, s equal to ut plus half at square, and v square equal to u square upon v square equal to u square plus 2as. Now here also we have the same equations, but there is the difference of notations. Here we take the angular velocities and angular acceleration. So initial velocity given to now 0 and finally given to now v naught, and this velocity is attained in nth round. This is to be remembered, nth round. This is the main thing. So the omega square equal to omega naught square plus 2 alpha theta. Now given. Now this omega naught equal to 0 and omega equal to v upon r. So it's now v naught upon r. This is given. And theta. Nth round. In one round the displacement is 2 pi. In nth round this will be 2 pi n. This is now 2 pi n. So much radius. Now put all the values. This is v naught upon r whole square. This is now 0 plus 2 alpha theta. This is now 2 pi n. Then you can find it that this alpha equal to v naught square upon this is now r square. This is now 4 pi n. 4 pi n. This is now r square. So much radian per second. This is the angular acceleration, so that option corresponds to 4 pi n r square, 4 pi n r square, v naught square. This is now your option number 4. So our answer must be 4. So this is the direct application of the equation of motion for the circular motion of the particle. And now we come to question number 20. A person is standing on the floor. Person is standing on the floor of an elevator. Drops a coin. Drops a coin. The coin reaches the floor. The coin reaches the floor. In time t1 if the elevator is at rest. If the elevator is at rest. And in time t2, in time t2, if elevator is moving uniformly. Elevator is moving uniformly. Then we have the options. First is T1 equal to T2. Second, T1 less than T2 or T1 greater than T2, depending upon whether the lift is going up or down, up or down. And now option third, is that T1 is less than T2, and fourth is T1 greater than T2. Elevator means the lift. When the elevator is not moving, it is at rest, then the coin is dropped, so it takes the time T1 to reach at the floor. And when the elevator is moving up or down, again the coin is dropped, then this take the time T2. Since the elevator is moving uniformly, so it has no acceleration at all. It means that whatever the time will be taken by the coin to reach at the floor, that will be equal. Because it is not accelerated, and moreover, the value of G is not changing at all. So now solution is what? Or uniformly moving elevator, the value of G does not change. Or so T1 is equal to T2. Time will be the same, whether the elevator is at rest or it is moving uniformly, time will be equal. So our right option must be first. We have the answer. First. Now the question number 21. A truck is stationary and has a bob. A truck is stationary and has a bob and has a bob suspended by a light string. In frame attached to the truck. Attached to the truck. The truck suddenly moves to right. The truck suddenly moves to right, with an acceleration of a. The pendulum will tilt. The pendulum will tilt. Number one, to the left, and angle of inclination to the left, and what is given, angle of inclination, angle of inclination of the pendulum with vertical this is vertical is sine inverse, no, this is the tan inverse G upon A. Now second option, to the left and angle of inclination of the pendulum with vertical is sine inverse this is your G upon A. And third option is to the left and angle of inclination of the pendulum with vertical is tan inverse A upon G. Tan inverse A upon G. Fourth, to the left and angle of inclination of the pendulum with vertical is, this is your sine inverse A upon G. This is the question. Options are given here. So now for its solution, we are given a truck and this is suppose the support and this is the bow. This is the bow hanging vertically downward. This is now one of this truck and this truck is moving. Suddenly it moves to the left, so towards the right. So this is now your left side, and this is now right side, and this is left side. Now the truck moves in this direction. So because of inertia it will remain here, truck will go ahead, then this will be deflected towards the left. So here is like this. The truck is moving like this. This is now A, acceleration. Here we have the gravitational acceleration, this is now equal to G. So whatever to here, this is also equal to now A. This is acceleration A. This angle is theta. So due to inertia, this is suppose A. This is we have this point P. This is now suppose point Q. Due to Newton's first law, the bow, the pendulum will tilt to the left. Because truck is moving towards the right. For truck moving to the right. Now this is the angle. So this is now right angle triangle SPQ. Right angle triangle. This is now your SPQ. Now here we have this tan inverse tan theta equal to this is now this PQ upon SP. So this PQ tan theta, this will be represented by this A, the acceleration in this way. So this is now your A and this is now your G. So from theta equal to tan inverse A upon G. So this is the horizontal side of the triangle. This is the vertical side. So perpendicular upon the base, that will give you the value of theta. So the pendulum must be tilted towards the left and the angle with the vertical will be A upon G. A upon G. So now we have the right option is third. This is now third. Left, and the angle of inclination of the pendulum with the vertical is tan inverse A upon G. So our answer is third. This is the question number 21. And now question number 22. Here given two toroids 1 and 2. Two toroids 1 and 2 have total number of turns. Have total number of turns, that is 200 and 100 respectively. With average radii radii 40 centimeter and 20 centimeter respectively. If they carry same current, if they carry same current I, the ratio of magnetic fields magnetic fields along the two loops is, and now options. Now first option is given here, that is 1:2. Second is 1:1. Third is 4:1. And fourth is 2:1. Now the solution. You are given the toroids. This is the direct application of the magnetic field of inside the toroids. So for toroids B equal to mu naught Ni. Now here this mu naught N is equal to N upon 2 pi r. This is equal to I. Small n is the number of turns per unit length. Since the toroid is circular, so length is 2 pi r. So here you put the values B1 equal to mu naught N1 I upon 2 pi R1 and B2 mu naught N2 I upon 2 pi R2. This is given to us. So this B1 upon B2. You see that all quantities will cancel except this N1 upon R1. So this is N1 upon R1 into N2 upon R2. So now you keep the values. N1 is given to be your 200 turns and radius is given your 40 centimeter. This is now your 20 centimeter. This is now your 100. So much. Then you cancel this and cancel this by this 2 by this 2. So what is left? 1:1. All quantities have been cancelled. So the ratio will come out to be 1:1. So either right option is second. This is not right option. So this is the direct application of the magnetic field inside the toroid. And here you have to remember that the value of n will be found out like this, n upon 2 pi r. Not by n upon L. N upon L is used in case of the solenoid. There we have this mu naught n I upon L, capital L. So by using that for the solenoid, but here we have given the toroid, so you have to use like this. The ratio of these two magnetic fields will come out to be 1:1, or they have the same or the equal magnetic fields along their axis inside the toroid. So this is what the questions from up to 22, and next I will take on the next lecture. So you all like, share and subscribe the video. Thank you very much.